Math 3, Unit 8, final review. The first thing we're going to talk about is the different types of sample methods. First of all, most of these are simple random sample methods. We're going to cross this one out, and I want you to add in stratified. Okay, and we're going to number these. So this is going to be 1, 2, 3, and 4. Okay. So I'm going to briefly talk about these, and then we'll go through all the examples. So systematic is normally when you have like a set of data and it's numbered, and then you go through and say, okay, I'm going to start with number 5 and then pick every 15th or something like that, okay? So systematic, there's a system, and normally it's like 2 steps at least, okay? Stratified, does anybody remember what stratified is? No. So stratified's where you split them into groups of people, and then from there you take a random sample from each of the groups. Okay. Self-selected, that is when you are selecting yourself to be in a yeah. And actually, maybe we need to keep, I just realized this. Let's keep some simple random sample, because there is one up here that's just a regular random sample. We'll call that 5. Okay, anyways, so self-selected. So if I think the one that we talked about in this unit was you are in a meeting in the gym or something, and they're like, well, we want to take a survey of water usage. And so whoever can stay after and take the survey, please do. So you are selecting, you yourself are choosing to participate in that survey. It's not someone's choosing you. Does that make sense? Okay, so self-selected is when you are selecting yourself to be part of something. Okay, and then convenience is where you go into the store and say you want to see how many colors in the M&M's bags or how many, and then you just grab the first 5 or whatever, because that's convenient to just take those. Okay. All right. So let's go to A. And so you have numbers 1 through 5. What do you think A is? So on your fingers, you can show me 1 through 5. I mean, yes. I mean, yes. 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 Okay, so this one is convenience. Okay, because they're needing to check the bags, the inspector just takes the next 50 bags. So he doesn't like take every 10th and wait for 1,000 or go to different belts and get chips from each month. He's just taking the first 50, seeing what happens. So that would be a convenience sample. Okay? B. Good. Actually, okay, so this one is your simple random sample. So this is just where you number your list and then you randomly pick numbers from that list. Does that make sense? So that is your simple random sample. Your systematic is when you have more steps to it. Like where you choose the 5th number and you take the 15th one or something like that. Okay? So, what is C? Yes. What do you guys think C is? So 5 is simple random, just so you know. This one is. 2 is stratified, 1 is systematic. Stratified is when they divide into groups. So see how they're divided into groups? Okay, and you have freshmen, sophomores, juniors, and seniors. And then from each of those groups, they take a random sampling. Okay, so that is your stratified. Okay, and then D. What do we think D is? Good. So D is systematic. And if you have your old notes, I would recommend going back and reading through some more of these examples if you have your Unit 8 notes packet. I feel like there were like at least 4 questions on the final that ask these, like just naming them, which is a pretty easy problem to get right as long as you understand what each of these are. Okay? All right. And you'll get some practice in your homework too. Okay, standard deviation. So right here, this is just an example of standard deviation. Remember, this is your symbol for standard deviation. This is your symbol for variance. So I'm just going to kind of walk through what you do in order to get it. First of all, you need to remember that your standard deviation can never be negative. Okay? The standard deviation describes a distance. It's a distance between each of the numbers in your set of data. Okay? So here's an example. The first thing you always do is you have to find the mean. And remember that X with the line over it, that means mean. Mean is where you go through and you add up all of these numbers together to start with. So when these all get added together, they equaled 860. And then in order to get the mean, you divide by how many numbers you have in your data set. And in this case, if you count, there's 10. And so 860 divided by 10 gives you 86 as the mean. Okay? Once you have the mean of your set of data, you go through and you take each piece of data and you subtract it from the mean and square it. So 85 minus 86 squared. 87 minus 86 squared. 90 minus 86 squared. And then all the way through every piece of data. Okay? Then you add those up and take the average again by dividing by 10. So when you added all those up, it equaled 30. And 30 divided by 10 is 3. And this value is for your variance. And then in order to find the standard deviation, you take the square root. Okay? And so this is the standard deviation of this set of data. Okay. Any questions? Okay, we're going to move on and we're going to try an example on our own now, or together, but without all the work done for us. Okay.
Excuse me?
Yes.
Could you do flag salute?
Yes, as soon as we're done with notes,
Okay.
we will do the flag salute.
Okay.
Thank you, Tyler. Okay. All right, so what is the first thing we have to do? Add them all up together. Okay, so why don't you guys go ahead and use your calculators. Let's add all those up together and let me know what you get. Oh, the mean. Okay, when you add them all up together, it equals 602. And then I'm going to divide by what? By 7, which equals 86. So my mean is 86. Okay, now the problem we did previously lined them up differently, but I like to just kind of make a list. And so I start with each of my numbers, and I'm going to go 97 minus 86, which is 11, and we square it, which is 121. And then I have to do this to each piece of data in this data set. So we have 75 minus 86, which is negative 11, squared is 121. 80 minus 86 is negative 6, squared is 36. 90 minus 86 is 4, squared is 16. 71 minus 86 is negative 15 squared, which is 225. 99 minus 86 is 13, and 13 squared is 169. And then 90 minus 86 is 4 squared, which is 16. Who remembers what we do after that? Good. We take all of these numbers right here and we add them up together again. $704? 704. And then we divide that by 7, which ends up making 100.6. Okay, that value right there is my variance. How do I find my standard deviation? Good. So the standard deviation will be the square root of 100.6, which is approximately equal to 10. Any questions? Okay. 5-number summary and box and whisker plots. So basically, this just reminds you that sometimes standard deviation kind of tells you how your data is spread. Sometimes it's better to do a 5-number summary and a box and whisker plot. You need to remember what skewed left, right, and normally distributed looks like. Okay? Yeah. What do you guys remember when it says that it's skewed left, what the graph kind of looks like? No. Yes. So skewed left, oh wait, yeah. It's where most of the data is actually on the right. Your thinner piece, like the small part, is on the left. Okay? And then remember your 5-number summary box and whiskers looks like that. Okay, and so skewed right, so whenever you're saying the skewed part, it's where the thinner part is on the right. And so this would be an example of skewed right. Remember with your bar graphs, it's the same idea. Okay, so if it's skewed left, the thin part would be on the left. Okay, and then normally distributed would look something kind of like this. So in order to create a box and whisker plot, you need to know your 5-number summary. Okay, and so here is your information for your 5-number summary. You have your smallest value or your low, your highest value or the high. Your median is always in the, remember that your median is in the middle, okay? Once you have that, then the first quartile, Q1, is the median of the first half of data, and then Q3 is the median of the second half of the data, okay? Now, one thing that I didn't list here is outliers, and you need to know how to find outliers. Does anybody remember how to find outliers? Then you usually can guess it's one. Exactly. The actual formula for it is you start by finding the IQR. Does anybody remember what IQR stands for? Very good. Interquartile range. If you want to write that down, you can. I do not want to. Okay. So your interquartile range is Q3 minus Q1. Once you get that value, you take the IQR and you multiply it by 1.5. whatever that value is, for Q3, you add the IQR times the 1.5, and since I don't know the value, I'm just writing it like that, and that gives you your upper boundary. And then Q1 minus your IQR times 1.5 gives you your lower boundary. So interquartile range, multiply it by 1.5. Whatever number you get for that, you add it to Q3. If there's anything above that value, it's an outlier. You subtract it from Q1. If there's anything below that value, it's an outlier. Okay. Any questions there? Okay, so now we're going to try an example. Okay, the first thing is that you always want to make sure that your data is in ascending order. To make life simpler, this already is in order. Yay. Okay, so let's figure out these values. So to start with, we already know what our low value is. What is that? 5. Very good. So that is my low. And then my high is 32. We need to know in order to find the median. You can like use your fingers and go through, but I think that even better to make sure you don't mess up is to number your data. So I'm going to go through and number these. And I can see that there are exactly 14 numbers. What does that tell you about your median? Yeah, you're going to have to take the average of two numbers. There isn't an exact middle number, okay? And so my median is going to be right in between 12 and 15. So 12 plus 15 divided by 2 gives me 27 divided by 2, which is 13.5. If you had a median, okay, let's say it was an exact number, you wouldn't be able to use that with finding your Q1. But since it's not an exact value, I can still use all of these 7 numbers to find my Q1. So since this was the average of two numbers, my Q1 is going to be an exact value. So what will be the value for Q1? 7. That is your Q1. And what will be my value for Q3? Good, 21. Okay, any questions on that? Let's go ahead and practice finding if it has any outliers. Okay, so what is the first thing I would do for the outliers? Good. Q3 minus Q1, and so that is 21 minus 7, which is 14. Good. Now what do I do with that number? Good. We multiply 14 times 1.5, which equals 21. So what that means is for my upper boundary, I would take 21, which happens to be that number, plus 21, which is 42. So if there are any numbers above 42, it would be an outlier. But in this case, do I have any numbers above 42? No. And then for my lower boundary, I would take my Q1, which is 7, and subtract 21, which gives me negative 14. And are there any numbers that are smaller than negative 14? No. So that means there are no outliers. Okay. Any questions on that? Okay. So when you are drawing a box and whisker plot, you want to make sure that your marks are proportional, so your box and whisker plot makes sense. because oftentimes they'll ask you to say, is it skewed right? Is it skewed left? And if you just mark a 5, mark a 7, mark a 13, and so on, you can't really tell how it's skewed. Does that make sense what I'm saying? And so I'm going to go ahead and start this one as 5, but then I'm going to count all the way up to 32. If you wanted to count by 5s, but just kind of try to make your marks consistent, that's fine. Okay, so I'm going to go to mark these. Okay, so I have my low value marked and my high value marked. Yes? So we found our upper boundary, which was 42, and there's no numbers that are above 42. Like, let's say 50. If 50 was at the end, then that would have been an outlier. Exactly. So you're looking for that value if there's numbers above it or below it. Okay, so then the next mark I have is at 7. So I have a mark right here. And then 13.5. And then 21. So remember, your box goes around your 3 middle numbers, and your median has a line going through that in the middle, and then your whiskers go out here to each of the ends, connecting with those last points. So how would you describe this data? How would we label it? You always label it with the thin part. So that would be skewed right. Look on your paper. Like, this is to the right. Correct? Okay. All right. Any other questions with that? Okay, the next thing we're going to talk about is percentiles. So finding percentiles, you need to know the number of data values you have. How many items are in your data set, okay? And then you multiply it by your percent, but you need to put your percent as a decimal. Once you get that answer, then you end up going to that point, that number on the graph. Okay, remember on this one, if you get a whole number, you end up giving it a 0.5, and you find the average of the two numbers. Okay, if you get any decimal, you round it up to the next number. Okay, so here's a couple examples. Here's this data set right here. If we were to number these, in fact, let's go ahead and number these. So it goes to 20. 1, 2. So my n value is 20 because there's 20 numbers in the data set. If they want the 37th percentile, you take 20, you multiply it by 0.37, and you get 7.4. Anytime you get a decimal, you round it up to the next number, which is why they get 8. Now, 8 is not the answer. It means that the 8th number in your data set is what is the 37th percentile. So if you go here, that value is 32. So the actual answer is 32 because 32 is at the 37th percentile. So like in terms of scores, it would mean that that would be your value. If you were in the 37th percentile, your score would be 32. Okay, so on this one, again, there's still 20 pieces of data. We want the 60th percentile. 20 times 0.6 is 12. Okay, and so we have to add 0.5 to it. So that means we're going to go to 12.5, which really means you're taking the average of the two numbers, 12 and 13. So when you add those together and divide by 2, you get 67. So my answer for this one is 67. Okay, we're going to try one on our own now. The first thing, though, that you always need to do is make sure your data is in order. Okay, so we're going to list it in order. Normally, as I'm writing these down, I will mark them off because this sometimes it's confusing with all those numbers. So we have 2. And then next is 5, 11, 15, 17, 21, 31, 34, 48, 50, 56, and 76. Okay, after you have them in order, in ascending order, I would then number your data set. Cell phones away. Okay, so number our data set. 1, 2, 3, 4, 5, 6. Okay, so I have 12 pieces of data. We want to find the 45th percentile. Okay, what will I do? Good. 12 times 0.45, and when you multiply that, it equals 5.4, which means we would round it up to 6. So if you go here, the 6th number is 21. So the 45th percentile is 21. Okay, so now let's find the 90th percentile. What will I do? Good, 12 times 0.9, that equals 10.8, so we're going to round that to 11. So we go to the 11th number, and it is 56. I'm going to add one more to this, and let's find the 50th percentile. So if you wanted to be in the 50th percentile, where would you need a score on this? And so you would take 12 times 0.5, which is what? 6. Because it's 6, that means we're going to take the average. We're going to go to 6.5, and so we're going to take the average of those two numbers. And so we would take 21 plus 31 divided by 2, which ends up being what? 26. Okay, any questions? Oh, do we need this for another minute, or are we okay?
Another minute.
We're good? Okay. Next, we're going to talk about the empirical rule. Do you guys remember this?
Kind of.
Okay. So, I drew the curve for you. So, if we were to split this in half, we know 50%'s here, 50%'s here, correct? And then each of these is one standard deviation. So, this would be one standard deviation, okay? From here to here. That's one standard deviation. One in each direction, okay? 2 standard deviations would go out all the way there, and then 3. Now, 1 standard deviation is equal to 68%. So if you are splitting that between these two numbers, they each are worth 34. And I think it is easiest to end up writing it out this way with the percents here. It'll help you with your answers, okay? 2 standard deviations is 95% of your data, okay? Now, just with like 68, I took 68 divided by 2, which gave me 34. If I take 95 and divide it by 2, it equals 47.5. But this is 34, and from here to 2, from 0 to 2, it needs to equal 47.5. So what piece is missing right there? 13.5. Okay, and you could go 47.5 minus 34, and it equals 13.5. So that means in each direction, that is worth 13.5%. Now, 3 standard deviations is 99.7% of the data, which we end up approximately rounding to 100%. Okay, well, if this side is supposed to be 50, right? How much is missing in order to make it 50? 2.5. Okay, and so on each side, these are 2.5. So once you have that information, it makes all the other problems a little bit easier. So let's go ahead and read our next problem. It says, a class recently took an exam for a math class. Okay. The average for the class was 80% with a standard deviation of 5%. Assume the distribution of the class exam scores to be normally distributed. Drawing a curve can help visualize the problem. So what we're going to do is, when it tells you that the average is 80%, what does that tell you? What should you do with that information? Average 80. That means going through the middle, that value right there is 80. When it says with a standard deviation of 5, that means each standard deviation you would add 5 or subtract 5 depending on which way you're going. Okay, and so if we put these marks in, this would be 85, and this would be what? And going back this way, we would what? We'd have 75 and 70. And again, I would practice by putting in all my percents that go here. So this is 2.5, this is 13.5, 34, 34, 13.5, and this is 2.5. Because now each of these questions, starting with A, it asks, what percent of the students received a score of 85 or higher? So all we're doing is, this right here is where 85 is. So you're just adding 13.5 plus 2.5. So what percent? 16%. 13.5 plus 2.5 equals 16%. Okay, B, what percent of the students received a score between 70 and 85? So 70 to 85. Okay, so however you want to add that, but we're adding 13.5 plus 34 plus 34, and it equals 81.5%. Okay, if the class was composed of 35 students, how many students received a score between 90 and 85? Well, what percent is in between 90 and 85? Okay, so 90 to 85 is 13.5%. Okay? In order to find out how many people would be in that group, all you're going to do is take how many numbers there are, how many students there are, which is 35, and you multiply it by your percent. So what decimal would that percent be? 0.135. And if you plug that into your calculator, it equals 4.7, which we would end up rounding up to 5. So that means there would be 5 students that were in that range. Okay. Last thing, z-score. And on your test, they're going to give you this formula, but they're not going to tell you what everything means. Okay, so this will be written down, but you don't know what this means. Do you have a question? Okay. So X is the mean of the actual data. Oh, sorry. I'm lying to you. Okay. X is the score that we're talking about. Okay. This Remember, it's like a mu. That is your mean, and then divided by your standard deviation. So if you're looking at this information, and this is how it's going to be, they're going to tell you that the average score for the class was 75. Where should that 75 go? For your mu, or your mean, okay? The standard deviation for the class is 10.3. So down here, this is where your 10.3 should be. And it said that you scored a 93. So a z-score is finding the exact location of where you are in a data set in terms of standard deviation. So if we go through and do this, we end up getting 18 over 10.3, which is 1.75. And make sure you pay attention to positive and negative. So that means your positive 1.75 standard deviations from the mean. Okay? So if you wanted just to write this out, we could put you are positive 1.75 standard deviations from the mean. Okay, any questions?